The next talk is by Johanna Gerlach from the...
I'm Marianne Starlander. Sorry.
Next talk is by Marianne Starlander on behalf of a large group of authors about evaluating a multilingual pre-trained model for the automatic.
Thank you very much. You can hear me. Yes, okay. So as just heard, I'm on behalf of my colleague, and the study I'm presenting today has been conducted in the framework of the STARS project. This project is an IME project, so it's an Initiative for Media Innovation project, and we have been collaborating with ReCap and the Swiss TV. So the aim of the project basically is to propose to make content accessible in Swiss German TV. Probably familiar. You will typically have some interviews or TV reports and shows where you have Swiss German, and the idea is to make this content accessible to people who don't speak, understand spoken Swiss German. So our approach, well, the aim is to produce good quality captions, and our approach is a cascading approach. So we have basically two steps. I guess from the audience that you're familiar with Swiss German, but just in case, I remind you that Swiss German is a spoken language, and with many different forms. So there's no standard written form. There's this first step, which is done by our partner ReCap, where you actually produce from the automatic speech recognition this normalized Swiss German transcription, where the syntax would be the original Swiss German syntax and the vocabulary as well, but it is in a written form. But so far, classic automatic speech recognition will not produce good enough quality to propose captions to end users. So we are adding the second step, which is machine translation, if you want, where you would start from the normalized Swiss German transcription and end up with the standard German output of good quality. So this is what our project and AI system aims to do. This second step permits us to correct a certain number of error types. The first error type would be when there is a divergence, or there is a difference, for example, in syntax, Swiss German and the German. So we have this first example here, where the word order is different. Der einzige Ort, wo ich würde gehen, ist Spanien, would be transformed into der einzige Ort, wo ich hingehen würde, ist Spanien. This is one first type of errors that our systems try to corrects. Other typical errors that our systems aims to correct are the spoken language phenomena like fluencies, informal language, and ill-formed utterances. So here you have a typical example when you have an M in the middle here that has been removed. And then finally, there is this third type of errors that we aim at correcting, always with success, where some automatic speech recognition typical errors like phonetic errors, like homophones, for example, would be corrected by our system, or other meaning errors. So let me just, before I go ahead with explaining how the system works, give you a short example here, illustrates what the aim of our project is with this example here. Just, you will see in this short video some errors that are orange errors that are fluencies, purple are automatic speech recognition, and blue are Swiss German specific elements. And all that you can see in green has been changed. So I know you don't all speak Swiss German, understand it.
Also im Zug im IC nach Basel und Freiburg hat Abteilungszentren genutzt. Und Druckweg jetzt der ganze Gallier dann fragt man sich natürlich schon, ist es richtig, wenn man es macht?
Okay, so the first line was the automatic speech recognition, and the second line was the results produced by our system. I've heard some people laugh, so indeed, there are some errors that could not be corrected. So that was the kin, which is actually not quite the same. You can see here in the remaining example here that that's typically a discrepancy that has been corrected. So this is just to give you a sample of what our system does. So I'm speaking now at the end of the project, and in the course of the project we had, of course, different challenges. The first challenge would be that we needed to develop our own specific training corpus to go from automatic speech recognition to standard German. So I'll speak about the different corpus we used in a minute. Then the second step was during the project was to test several models and automatically evaluate and find out which is the best suited architecture to achieve our goal. And what I'm presenting today is part of the third step and last step, and I'm going to speak more specifically about there are human perceptions about the changes that were made by our system on the automatic evaluation. So it's really a human evaluation I'm presenting today. So first, a few words on the resulting system. So I'm not going to describe the different steps. There's a paper going out about that. So, but briefly, this resulting system is a multilingual pre-trained model, the MBART 50 model, that has been fine-tuned on this three different types of data. Well, data number earlier was small. This is really small. Okay, and basically for the first set, the bilingual corpus of TV shows, we used this alignment from automatic speech recognition to normalized Swiss German, and we actually did that with human post-editing by our students. Okay, so it's really a precise corpus here, but small, since it's 80,000 segments only. This specific resource for our task was backed up with this bilingual corpus of the Swiss Parliament, you might be aware of. And finally, also some monolingual corpus of German subtitles. So basically, in previous work, you can read how we got to select this architecture. And using this specific data, because we tested different data, get to this resulting system that we have now in this study evaluated. We did two types of evaluations. So the main idea is the aim of our system is to improve the automatic speech recognition, but keeping as much as possible from the automatic speech recognition and provide some correct captions. So we did first, we compared the raw automatic speech recognition to our model, or the output of our model, and on two aspects, language and meaning. And then obviously, ChatGPT was launched at the end of the project. So as Anne said earlier, we could not, we had to test and investigate how does ChatGPT perform on this task, because we have seen that ChatGPT could outperform on minority languages, on certain NLP tasks. So how does it work on this task? So the evaluation was a classic evaluation where we asked 4 participants. So obviously they had to be Swiss-speaking and German-speaking, but with Swiss background, to be able to participate. And they were asked to use this classic spreadsheet environment to evaluate 400 segments, where they had to make a comparative evaluation on 2 aspects, so language and meaning. So well, of course, the display was randomized, so you didn't know where it came from. And so they had to choose if A was better than B, A and B are equivalent, and B are better than A. And there's a specific scale of language and other aspect of meaning, where you would, the testers have to say if A was better than B, both were correct, both were false, and B was better than A. So the results for the first study, where we compared the raw automatic recognition result with our model output, you can see here that you have quite a good agreement here, because there is usually a majority comes up in 84% of the cases here for language. And clearly in this first study, our system output is better than, is judged as better than the automatic speech recognition. And what is also important, well, that is for the language. For the meaning as well, our system, the output of our system is better by 40%. And which is also important is that there are very few occurrences where the automatic speech recognition was actually better. Okay, so that's only 2% and 1%. Right? So those results are quite clear cut by our human evaluators here. Now on the other task, which is task where we compare ChatGPT output with our model's output. Well, first of all, you can see that the results are not that clear cut than for the first part, since there is no majority for 29% here and 35% meaning here. But what is interesting, of course, is that ChatGPT, for this study by human judges, actually received better 45%, 45% times results, and when our system, the MT result was better than ChatGPT, only 11%. That's for the language. We are going to see some examples and go further into the results. Obviously, we are aware that ChatGPT is able to produce fluent, looks nice sentences. Okay, so we'll see some examples. The meaning, as you can see, there is ChatGPT only it's 26, it's more than ours, but receives a majority for 26% of the case in the meaning. So obviously the language is much better, say, than for the meaning. So what happens? The aim of this system is, our system is to provide captions. Captions need to be as close as possible as what has been said. So now if you take a closer look at some examples here by ChatGPT, for example, here you have first automatic speech recognition and then the production by ChatGPT. Well, first of all, you can see that it's much longer, so ChatGPT tends to make a lot of insertions or additions to the sentences, and also it produces something that is much more similar to written form. So it's not the same register. The captions that are used here are much longer, so only too long to be read. So it's not really suitable for our usage, since we are aware that captions has to be short enough to be read. And here the style is totally different. So if you have a look here at what has been added, it really gives a written formal touch. You have all this red part that is added. Also, you can see the ich has been added in that part. So this is really a reformulation that is quite typical by ChatGPT. Okay, but then there is also, because we asked during the evaluation, asked our evaluators also to use comments about what I evaluated. And one of the typical comments that came up is that the accuracy by ChatGPT is not reliable enough, since there are some examples, and here some differences. Sorry, where here you can clearly see a difference between what has been said. Well, there is a clause in English, so something like they didn't do anything at the pinna, was transformed by ChatGPT, but they didn't do anything despite demands from the pinna. So it sounds good, it looks good, but it's not. So basically, this kind of example, and that's something that our evaluators highlighted, makes the use of ChatGPT not, well, it doesn't suit the end user, well, what we want. We want something much more closer to what has been said. We want to understand what they're saying. Okay, so basically, those paraphrasing can change meanings. So you can see that this is a complex task to evaluate, but to make a wrap up about what we saw now, we can see that the result of the study actually suggests that in a context where there's a few tasks, specific resources available, this kind of system where we fine-tune the embark system on specific data gives a promising, well, shows a promising approach. That is our results by our models permits us to improve the automatic speech recognition, which was the aim of this model. And then, obviously, as you already talked about ChatGPT, now with the prompt that we use, you can read in the paper the exact prompt. I can show it to you once in it. This produces a more fluent standard German. Sounds nice, looks nice, but transforms meaning and the paraphrase that are generated can be dangerous. So, since our aim was to produce something quite similar to the original, this you do it. So probably we could try some more prompts, and the original prompt here used. Maybe the idea is that we could ask ChatGPT to be more precise, to stay closer to our original. Because the prompt was, "Hi GPT, can you help me with the following task? I want to correct transcripts of Swiss German audio files. These transcripts are in an incorrect German grammar. The goal is thus to correct transcripts to create proper German text." That was the prompt. So, of course, in this prompt, there is not probably enough information about staying close to the original. This would be something that test. And thank you for your questions now. Thank you for your attention. I'm not sure how much time I took. 2 more minutes.
Very often the text is short, then have you that way out and shorten as well, or just
No, that was one of the challenges when we wanted to fine-tune our system, because we had also a set of human-produced equivalent to the ACR. We had some subtitles. And as you say, subtitles are shortened, are synthesized, and so on. So this is actually different to the transcript. Transcript is longer. So actually, it will now depend on the end use of the model. Basically, the first use would not be faulty. We public like we are, but rather for journalists to go back to a show or something. So in that case, they rather want some transcripts. But if you are true, it's true that you want to use really for TV public. It should be as shortened and as precise as possible, so that you can't do the job. Long.
No, you can make prompts saying what that.
Ah, you mean the prompt?
No,
yeah. Subtitles.
Summary of work.
Yes, we haven't asked him to do it directly. Have you ever tried that out? Have you tried it out? No, I mean on subtitles.
No. Not yet. No, but you could actually like evaluate our.
Mm-hmm. Yes, you have a. Yeah. Well, actually, the subtitling, the raw material we're using comes from our partner Recap. So that's the RCR, the automatic. And the subtitles were provided from Swiss TV. That's quite different. You know, we got this problem where we had the automatic dictation from one side and the subtitles on the other side. Difficult to align those because they are different. Yes?
I have two questions about this. First is, did you establish your own set of guidelines for the moment? How did you start?
You talk about the normalizing step here? Well, that is actually our partner, Recap, but I'm afraid to answer the first question. I hopefully can answer the second question. Well, we use actually, yes, I do have some idea. We have, yes, sorry, I do know that actually. My colleague Johanna has previously done some guidelines that she needs to check the tag data and come up with a couple of rules to help those with normalizing. Yeah. So there are guidelines.
Then how do you start to ask yourself or
which one?
That normalization itself, like why those rules?
That was Recap. We really did this. Sorry?
It's not good. So the question for our responsibility, so if you push in the same query, maybe and then you get different results every time. So are the results based on the first time you did the query, or you like replicate it and you put the ones where there were like different results
So actually, once the prompt I read to you was done, it was sentence by sentence, it was done. First ones I could have an effect as well on the rest. But that's we did it once.
The EXR on the blocks.
Yes, absolutely. Yeah.
Is it a problem?
No, it is not. No, it's not. No. Yeah, I guess you need to talk to them, but I remember it was an issue because we wanted to have it all open. Some of the material we used, like the, well, that was not, that's not what you, this monolingual corpus of German subtitles, there is a part that is, that doesn't belong to one TF here. So no, that's okay. It exists.
That's all.
Yeah. Yes.
I understand that your part is run by the inside the nonetheless paired with standard data. some communities like that, were asking about this.
Yeah, I think my colleague did that at some point, but I know we're not always happy about because we have to, when we intervene, for example, the error you all saw, maybe saw in once there is an error in here, well, not always, no, we start work on that part. Once the error is here, correct. So, I should ask my colleagues might tell you if they have done some thorough tests. I think we just decided to work with feedback anyway. So I'm not, well, I guess it's the best, but I wouldn't be able. Yeah.
But if the end goal is to actually have action, if a comparison to this kind of solution is
well, one element maybe I can give you is that our community languages were always very sensitive to if it was German or Swiss German in the SZ and so on. So using this recap system made it really more Swiss than if you use a general system. And well, maybe, well, that depends what is important for you as the results, but for the language, if there was a language part evaluated, it was quite often something that, well, the specific Swiss German elements were better in the system. But interesting question. I'll go with my colleagues. Yes.
Not sure if I missed it.
So you did not miss it in this presentation because this presentation is not really showing the technical side, rather what is the content. But there is a paper going out where you can find all the different technical challenges, different models, and other side. The evaluation plan. But Jonathan Mutal, my colleague, can answer.
How did you choose those?
That's good. I'm not sure. That's my colleague Johanna did that. And I guess since the perspective later is that maybe it wasn't too just specific enough. Sure, if it was maybe just let's try kind of way, rather than really maybe now we know that we should probably think of a bit more information. We want to get something more close to this our original text should tell.
Just about the data sets, you said part of the test purpose is accessible, and are any of the other ones?
This part here, this one here, is partly open. My guess is just one. I'm not sure about that, but I know that this part here is some of the.
Can we go see where you can see the part?
So it's the multilingual corpus of German subtitles. Okay. So the one here. Yes, sorry.
How did your model handle like this each has like other question mark or vacancy with those question cases where there's no real confirmation?
Well, actually, I've been sometimes aligning some of this. So sometimes I could see that it was a difficult task for some of the what you said and the homophones and so on. But those were actually kind of handled by those rules that my colleague Johanna set up. Like looking at the yes. that was something. This set of rules is in a paper at Albrecht. You'll find more detail about that part. There are a lot of challenges with Swift. Okay, thank you.